Hello, good evening, sir. My name is Joash Wesley. My matrix number is 01DKP24F2002. Sir, I'm here to talk about the electrical safety. This is the introductions. See, the electricity can kill or severely injure people, cause damage to a property. However, employees can take a simple precaution when working with or near electricity and electrical equipment to significantly reduce the risk of injury to themselves, to their workers or others around them. Sir, as you can see, the electricity is caused when not used in the proper way. So it may kill or severely injure to the other people also, and also the users or when we use also. This section provides a summary of those precautions. So this is electric hazards. As we see, the electric shock, current passing through the body can cause a burn, muscle damage, or cardiac arrest. Second thing is arc flash, a sudden release of electrical energy causing high temperature and light. Third is arc blast, a pressure wave from the arc flash that can damage hearing or throw workers backward. Electrical burns, tissue damage caused by the heat from the electrical fire and explosion, overloaded, secured, or spark near the flammable. Equipment damage is faulty components may lead to system failure. Sir, this is an example of in workplace as an electrical hazard. This is an international standard for the electrical safety. Use of electrical equipment, including portable airplanes, should carry out the visual checks. Employers and workers must remove the equipment from use immediately, check it, repair it, or replace it. As we see, the international standard for electrical safety. So when we use this electrical equipment, we must check it before when we use as a visual check, and we also have simply can't use that. And also, if we want to take it the electrical equipment where we took, that should the place we have to put it again after we used it. So the maintenance, the repair should only be carried out by a competent person, someone who has the necessary skills, knowledge, and experience to carry out the work safely. Visual checks are not usually necessary for small battery power items or for the equipment that works from a mains power adapter, laptops or cordless phones, etc. However, the main power adapter for such equipment should be visualized visually. So we can see as a visual check is not only a small small electric, something like a battery, not like that. It's also when we use a laptop or the phone or the charger. When you put the phone, then when you gone, suddenly will fire or make the electricity will shut down. So this is should, as we see the visual check all the area in the workplace. Employees must consider whether electrical equipment, including portables, should be more formally inspected or tested by the competent person team. The interval at which this should be done. So this is tools and the safety tools that we must use in workplace as an electric user. Cut cream, spike, repair. This is a nation standard for electrical safety. For the electrical grounding is the initial for the electrical safety. Involve the connecting electrical equipment to the earth. This provides in a pathway for faults and surge to discharge safely. Grounding also protects against the electric shock and electrocaution. It stabilizes secure voltage and reduces the risk of the contact with live electrical component. So in here, nation standard, they have electric cautions and the electric shock. So they want to protect themselves. They use a rubber glove, shelter tools, sleep resistant, comfortable shoes, goggles, and protective hats. All these must have tapes for secure office environments. So in the workplace, we should have safety equipment so that we can prevent from the electric shock. So make sure you have the right gear for every piece of equipment. This is a video, sir.
Safe work practices, the difference between life and death. Safe work practices around electricity can mean the difference between life and death. Dangerous working conditions can turn deadly when employees try to take shortcuts or ignore the safety guidelines set forth by the applicable codes and standards. Consider the following scenario. A foreman, who was an employee of an electrical contracting company, was called in to install circuit breakers in the main distribution panel at a commercial construction site. Electrical power from the local power company was connected to the commercial building's main distribution panel via feeder lines. The foreman decided to install the circuit breakers without shutting down the power, as this would require a 2 to 3 days advance notice to the electrical utility. Moreover, the incoming tenants in the office building did not want to shut down their computer servers. The foreman regarded installing the circuit breakers to be a relatively simple process that can be accomplished safely by relying on personal protective equipment only. Two other foremen who were not wearing any personal protective equipment stood about 10 feet from the distribution panel that is outside the arc flash boundary for that piece of equipment. The victim reportedly wore leather gloves over rubber insulating gloves, arc flash headgear with a face shield, and an arc flash jacket. The foreman uneventfully installed the first circuit breaker. As the foreman moved to the second circuit breaker, he accidentally made contact with 2 phases of energized circuitry with a screwdriver at the 3-phase distribution panel. This resulted in a blinding arc flash, followed by an explosion. The foreman was thrown backwards from the distribution panel due to the force of the explosion. He suffered first and second-degree burns on his arms, legs, and back. The other 2 foremen who were standing outside the arc flash boundary apparently suffered no injuries. OSHA investigation into the incident concluded that the arc flash and subsequent injury could have been prevented by adhering to basic electrical safety principles. First and most importantly, the main distribution panel should have been placed in an electrically safe condition prior to the installation of circuit breakers. The apparent justifications for failing to de-energize electrical equipment in this incident, which focused solely on the inconvenience of shutting power off, does not meet the necessary conditions for working on or near energized electrical components under the NFPA 70E. Moreover, the victim, who was designated by the contractor as a qualified person, was neither adequately trained nor qualified to work on energized electrical components. The foreman's lack of training and understanding of electrical safety principles was evident from his belief that he could safely install circuit breaker boxes on the main distribution panel without de-energizing it, and that personal protective equipment would be enough to shield him from electric shock or arc flash. While the protective equipment and clothing did protect the foreman to some extent, he still suffered serious burns on a large portion of his body. According to the hierarchy of controls, personal protective equipment must not be used as a first line of defense against electrical hazards. Instead, de-energization of energy sources is the preferred approach, and personal protective equipment may be used as a last resort or may serve to provide additional protection. It is important to note that the 2 other foremen who adhered to the electrical safety-related work practices and maintained an adequate distance from the distribution panel came out unscathed from the incident. This example demonstrates that violations of the basic electrical safety requirements as set forth by OSHA and the NFPA can result in devastating consequences. Employees, supervisors, and managers must be adequately trained to increase their awareness and understanding of electrical hazards in their workplaces and the safe work practices for working around electricity. Safe work practices.
This is from our Polytechnic Kumar standard for electrical safety. So as we have seen from the video that we should have like full PPE. Full form is personal protective equipment. So in the electrical safety, we should have to preserve the human life from preventing the electric, because the electricity is dangerous when poorly handled. Electrical safety minimize risk of fatal accidents. Second is to ensure the system reliability. A safe electrical system reduces failures, improving operational performance and productivity. Reduce the fire hazards. Proper installation, correct wiring in protective device and prevent the fire caused by current. So from here we can see as in our Polytechnic Homer standard also they say the electricity is dangerous. So we have to be careful when we are about to use electrical equipment, and we should visualize all the electric stuff and electric wires and also the wiring, and they're connected to the main switch. So when we are about to do something or to repair, so we should to turn off the main switch and we have to repair it, or we have to visualize it. So from the conclusions, electrical safety is the initials for preventing accident, protecting equipment, and ensuring the reliability operation of electrical systems. So you can see in my conclusion is by understanding assets such as electric shock, flash, and fires, workers can apply proper safety practice and comply with a standard like MSI EC 60364. This is from the standard nation. Consistent use of protective equipment, correct installation methods, and regular maintenance help reduce risks. Overall, strong awareness and adherence to safety procedures to create a safer and more efficient electrical environments. This is I to the reference International Labour Organization's topic as electric safety. Second is a good electrician's formulation. The good electrician topic is electrical safety tips. That's all from right now. Thank you.